a tree, and we have a person, this person, who starts at 4 meters east of the tree and walks to 3 meters west of the tree. What do you think the equation would be? Remember, this is displacement. Okay, so our little stick figure here started at 4 meters east of the tree, and then it walked to 3 meters west of the tree. So our equation is the displacement would be equal to the final displacement minus the initial displacement. So our final displacement is 3, but since it is 3 meters west of the tree, we know that it is negative because west is negative. So it's negative 3. And our initial is 4. And since we know that east is positive, this would be positive 4. So our equation would be displacement equals final displacement minus initial displacement. So our final displacement was 3 west, or negative 3. And then we would be minus positive 4, or east 4. So negative 3 minus a positive 4 is the same as negative 3 adding a negative. So it would be negative 7. Okay, so I just wrote it out in a different way so that you could see it. Displacement, so instead of having your negatives and your positives, you could also have it 3 meters west minus 4 meters east. And that's this, it would equal the same number, which is negative 7. Because negative 3 minus 4 equals negative 7. Okay, let's suppose we want to find the time that it takes this stick person to walk from this tree to this house. So when he's at the pond, it equals 0. And when he's at the tree, it equals 3. And when he's at the house, it equals 7. And these are all seconds, by the way. He's quite a quick walker. And how we calculate time is time equals final time minus initial time. Okay? So let's do the equation. Alrighty. So we know that time, how to calculate time is time equals final time minus initial time. So our final time is 7 because he was at the house at 7. And then our initial time is 3. So final time being 7 and initial time being 3, we do 7 minus 3. And our time is 4. Okay, so since we've done the calculation and we know that time equals 4, we know that it took him 4 seconds to travel from the tree to it. Uniform motion is a constant. It is distance over time. If you were traveling at 1 second and you were at 1 meter, then at 2 seconds you would be at 2 meters, and at 3 seconds you would be at 3 meters. Okay, let's go over uniform motion. So I just wanted to draw it out for you so that you could understand it a little bit more. So when this tennis ball, let's say it's at 0 meters, and so time is 0. And then it's at 1 meter, and it's 1 second. And 2 meters, 2 seconds. And 3 meters, 3 seconds. And 4 meters, 4 seconds. So it has to be the exact same counting. It cannot jump from, let's say it was 1 second and 1 meter. And this could not be 3 seconds for 2 meters, because that is a different different jump there, and that is not uniform motion, but this is. Alrighty, so let's also talk a little bit more about when an object hasn't moved. Is it still uniform motion? Okay, so let's say my tennis ball here does not move, but time still keeps going. Let's say at 1 second, or at 0 seconds, it is at 0. And at 1 second, it is at 0. And at 2 seconds, it is at 0. And it keeps going up. This is, in fact, uniform motion, because it is increasing at the same spacing, so the same area, same time. It is not changing. It didn't go from 1 second it was here, and then at 2 seconds it was at 3. And at 3 seconds it was at 7. It's not like that. That would not be uniform motion. But since it is in a steady place at the same time and it is consistent, it is uniform motion. Velocity can be uniform motion or ununiform motion. Velocity can be 1 second per meter, such as shown in this diagram of uniform motion. There can also be a change in velocity, and how you would calculate that is velocity equals final velocity minus initial velocity. A change in velocity occurs when the speed increases or decreases, or the direction changes, or both. It can be seen here in this diagram. At 0 meters, it is 0 seconds. At 1 meter, it is 1 second. And then at 2 seconds, it is 3 meters. Or 4 meters. So I'm going to show you the change in velocity. To calculate velocity, velocity equals final velocity minus initial velocity. But since we have 2 seconds for 4 meters, and we don't know what meters per second it is, we will just have to calculate that before we can continue. So let's do that. Okay, so here we have calculated the velocity for the final velocity because we didn't know what meters per second it was. So we did the calculation as velocity is distance over time, and I talked about this earlier. And so we have 4 meters over 2 seconds, which is in the graph here, or data table. And then we have velocity equals 2 meters per second, because if you divide 4 by 2, you get 2, and it's meters per second. So now that we know what our final velocity is, our meters per second ratio, and we want to find the change in velocity, let's do that equation. Okay, so velocity is final velocity minus initial velocity. So our final velocity was 2 meters per second, even though it was 2 seconds in 4 meters, we got it down to meters per second, which is 2 meters per second. So 2 meters per second minus the initial velocity, which was 1 meter per second, and you come down to 1 meter per second is your change in velocity. Okay, so beforehand we had talked about positive change in velocity, which was the video beforehand, and this one is going to be a negative change in velocity. So when you are decreasing your speed, basically, speed per meter, or second per meter. So here we have 0 meters and 0 seconds, 2 meters, 1 second, 3 meters, 2 seconds. So first we have to figure out our final velocity, which is 3 meters in 2 seconds, so that we can calculate the change in velocity. Okay, so we know that velocity is distance over time. So we have velocity equals 3 meters over 2 seconds. So velocity equals 1.5 meters per second. Now we can do the velocity change equation. Okay, so we had our final velocity, 1.5 meters per second, and now we know how to calculate the change in velocity. So velocity equals final velocity minus initial velocity. So the final velocity was 1.5 meters per second, and the initial velocity was 2 meters per second. So 1.5 meters per second minus 2 meters per second equals negative 0.5 meters per second. And that is how you find negative change in velocity. Okay, there is also constant velocity. And constant velocity is uniform motion. Because if you get your final velocity, your change in velocity equation, which is final velocity minus initial velocity, you would come out with the same number, or 0. They would be equal. So let's say our final velocity was 2. And so we have 2 seconds per meter. But that actually equals 1 second per meter. Or 1 meter per second, sorry. And then we had 1 meter per second, which is our initial velocity. And if we subtract them, we get 0. So that's a constant velocity. So, constant velocity is uniform motion.